Hello, I'm Drew, Application Engineer with Megger Instruments. In this video, we'll be discussing partial discharge in motors and how to detect partial discharge while performing a surge test with the Baker DX surge tester. But first, let's take a look at exactly what partial discharge is. During the coil winding and motor manufacturing process, it is possible to develop areas that are conducive to partial discharge. Bubbles or voids in the insulation can lead to such a condition. During the operation of the motor, these voids can become charged. At a certain charge level, this interspatial void will discharge itself. This discharge is not to ground or between conductors, but within the local void itself. These discharges can produce chemicals which are destructive to the insulation system, causing its life to be reduced. Voids can also form in the insulation system as the motor ages. This will cause partial discharge to develop later on in the life of the motor, driving it toward failure more rapidly. The presence of partial discharge can be detected while the motor is running and also while the motor is being surge tested. The Baker DX tester has the capability to detect high-frequency discharges associated with partial discharge during a surge test. The Baker DX will provide the voltage level at which the partial discharge activity occurs. This evaluation can be used as a quality check for a manufacturer or as a predictive failure indication by the end user during field testing. The presence of partial discharge can be detected while the motor is being surge tested. The Baker DX tester, equipped with the optional partial discharge module, has the capability to detect the high-frequency discharges associated with partial discharge during a surge test. The Baker DX will provide the voltage level at which the partial discharge activity occurs. This evaluation can be used as a quality check for a manufacturer or as a predictive failure indication by the end user during field testing. Now that we understand what partial discharge is, let me demonstrate how the Baker DX identifies partial discharge activity during a surge test. To begin the surge test, the first thing we need to do is select the surge icon on the screen. And if your DX is equipped with the partial discharge module, you'll have a PD icon that you can select, and it'll highlight green, activating the PD testing mode. If you don't have a PD icon, your tester could probably be set 10 and upgraded to include PD. Okay, so to do a PD test, of course, we'll have to hook up to the motor. So let's go over and hook the leads up. Okay, so the first thing we'll like to do is hook up the black ground lead to the motor frame. And we'll hook up lead 1, 2, and 3 to their associated motor leads, 1, 2, and 3. Okay, and then we're ready to test. So the partial discharge test is run very similar to a normal surge test, with the exception of once you get to test voltage, we'll also get to ramp the voltage down. And in that way, we're able to detect when the partial discharge activity ceases to exist. And we'll note the voltage at which that happens as well. So to begin the test, we'll push the push to test button. And for the surge, we have to hold that for the entirety of the test. Once we push the button, we'll have a new row of icons that are displayed. These will allow for changing the ramp rate, for changing the surge waveform scaling, and then finally for changing the partial discharge wave scaling. You can lock them, optionally lock them into one another, or make them independent scales as well. Okay, so as I showed in the previous surge video, I want to ramp the voltage slightly so that we can see a surge wave, and then use the scaling buttons to bring the surge wave into the scale of the screen. Okay, and now we're going to increase the test voltage. We're ramping in slow. And in this case, I'm going to ramp to 1500 volts. Okay, now with achieve test voltage, I'll stop ramping. So because this motor that I'm testing has partial discharge activity, you can see it was detected at 1460. And our PDIV was recorded at 1550. And now again, the only difference about how we do a partial discharge test is we also want to ramp the voltage down to record the voltages at which the partial discharge activity extinguishes itself. Okay. And once we're high volt, we can release the push to test switch, and we're completed with lead 1. We can see the partial discharge inception voltage recorded here, the repetitive partial discharge inception voltage, and then below those, the repetitive partial discharge extinction voltage, and then the partial discharge extinction voltage are recorded. Now, normally I would go on and perform testing on lead 2, and then lead 3, and then once I was completed with the testing, I would hit the save button, and of course we'd save it to the record that we want to save it to. And if I wanted to review the data, I can go to the reports icon, and then select the report icon there. And here we have a surge test. Record. I want to go to, there's the one I recorded that we just did, I demonstrated for you. So you can see the surge wave, all the values for voltage for each of the phases. And if you click the screen, as I just did, you'll get the house plot that shows the ramping and the deramping of the voltage and the partial discharge activity during the entirety of the test. So that's pretty much it. You can print that out from your DX, or you can export that data back off and use it with your Surveyor DX software. So now we can see how easy it is to detect partial discharge in your motors. For either manufacturing or for predictive maintenance, the Baker DX, equipped with the optional PD module, will show you the condition and quality of your motor windings. Thanks for watching.